In this video, we are going to learn adding and subtracting whole numbers. We have several topics in this video. First, we look at some basic operations, that is adding and subtracting. And then we look at some properties of addition. And after that, we are looking at how to solve a simple equation. And then in the end, we look at some application problems. Okay, let's get started. First, addition, subtraction are operations, arithmetic operations. When we add, we put numbers together to find the total amount. Let's look at our first example, say 5 plus 8. And I assume everybody can add single digit numbers together, right? And this is 13. So 5 plus 8 equals 13. Now, let's look at the second example, but not second example. Second question in the first example, 15 plus 8. Now we have a double digit number. Could be more digits. Usually, when we learn addition in elementary school, basically, we need to line up digits according to their place values. The digits with the same place value should be in the same column. So that's why we put 8 underneath 5 instead of underneath 8. I mean, instead of underneath 1. If you put it under 1, when you add them together, you get 95. And you know that doesn't make sense. How come 15 plus 8 equals 90 something, right? That's why we have this rule that when we add numbers, we put those digits with the same place value in the same column. Right? We do addition. Now this is a 13. We write down 3, and that 13. That 10 plus 3 is 13, right? Will be a carry to the next digit to the left. So this one, small one, actually equivalent to 10. That's why we put it underneath the 10th place. This digit has 10 is in the 10th place. So 1 plus 1 is 2. So we know this makes sense. 15 plus 8 equals 23. Now let's look at one more example. This time we have multi-digit numbers to add together, but general process is identical to the one we just finished. We need to line up digits according to their place values, right? So 5,408 add 916. Now we add digit by digits. This is 14. We have 1 as carry to the digit to the left. So 0 plus 1 is 1. 1 plus 1 is 2. Now we don't have carry this time. 4 plus 9 is 13. I have 1 carry. 5 plus 1 is 6. So final answer is 6,324. So today, everybody has a calculator, right? You can use calculator, but this basic skills we should learn. Everybody should learn how to perform basic operations without a calculator. And when we do things, especially in mathematics, by hand, it will enhance our understanding actually. So even if you have a calculator, try to do it by hand first, then you can use a calculator after you know how to do it by hand. You have an exercise problem, and if you watch my first video, you already know that I have exercise questions in each of these videos, and the answers to those exercise problems are in the comment area below the video. Now, let's look at our next topic. We are looking at some properties of addition. Now, the first one is called commutative property of addition. Commutative means exchange. You switch the numbers, just you switch the numbers so that the order of those numbers appear in the addition are different. The commutative property of addition says that if you switch the numbers in your addition, the result will remain the same. So as illustrated in this one, 5 plus 8 equals 8 plus 5. So both equal to 13, right? And this property of addition is called a commutative property of addition. Commute means switch this two, and without changing the result. How do we use it? How do we use this property? Look at the next example. So this time we are supposed to add the three numbers together. First of all, we could add 40 to 278 and get an answer and use that answer, then add to 60 to get our final answer. But since we know we have commutative property of addition, which means the order of those numbers in your addition doesn't change the result. So for that reason, I can add 40 and 60 together because order doesn't matter. I don't have to add the second number first. In other words, if I switch these two numbers, this is what I get. 40 plus 60 plus 278. Now we all know 40 plus 60 is 100, 100. 100 plus 270 must be 370. So this way, we don't even need to do actual calculation using those format. We can just do it in your head, right? In our head. So that's how we use this commutative property. You don't have to write it. This just show you how things work. You can just do this in your head by looking at it. 40 plus 60, 100 plus 278, that's 378. Okay, our second property is called associative property of addition. What this means is that without changing the order of those numbers in your addition, see on the left-hand side, we have A plus B plus C in that order, A, B, C. By the way, A, B, C's are, these letters are called variables in algebra. A variable is a letter that can hold different values. That's why we call it a variable. So let's look at this. These three numbers are together in the order of A, B, C. On the other side, you have same three numbers in the same order A, B, C. But what does this pair of parentheses mean? We all know this so-called order of operations. But here, this parentheses, we put it in the place just to show people if we do the first addition first, then we use the result add to C. It will be the same as that if we do the second addition first, then we use the result add to A. The result is the same. So in other words, this parentheses just tell us first we associate these two together, and then we could also associate these two together without changing the result. And that is called associative property of addition. In other words, you have two additions. You could even have 3, 4. You can do either one first without changing the result. You don't have to do it from left to the right. The difference between associative property and the commutative property is that for the associative property, you don't change the order of these numbers. For commutative property, you can switch the order of those numbers. Okay, now let's look at this example. Now we add 35 and 60 and 18. Let's just demonstrate this associative property. So I'm going to add the first two together first. So 35 plus 60 equals 95. Then I add 18. So I just do it in my head, and we can do it by doing this, right? 35 and 60, add them together, again 95. So I do it quickly so that we can focus on this associative property itself. When you add these two together, say 95 plus 18, we get 13, and we get carry 9 plus 1, 10, 10 plus 1, 11. So the result is 113. So in this case, we did the first addition first. So to indicate we want to do the first addition first, that's why they insert this parentheses into the expression, just to indicate to people, to the readers, that we do the first addition first. We could also do the second addition first in here. So it becomes this. Again, notice that the order of these three numbers never change. Now this equals, if we do second addition first, this is 78. So 35 plus 78. 35. 30 carry 3 plus 10, 10 plus 1, 11. So we get 113. See, the result remains the same. This is called associative property of addition. You have additions, it doesn't matter which addition you do first, the result is the same. But how do we use it? This is just demonstration of this property. How do we use it? Let's look at our example on this next page. Now, this is similar to the example we used for the commutative property. Now, certainly we can add the first two numbers together first. See, both are triple digits numbers. And we could also add the the last two numbers together. And you already know from the associated property of addition, this won't change the result. So if we won't change the result, we want to do it in a way so that we can do it a little bit faster, or in other words, more efficiently, right? So notice the second two, the last two numbers, 65 plus 35 is 100. Is 100. So 165 plus 35 must be 200. So 427 plus 200. So this is 400, this is 200, this is 600. See, we get our answer super fast. Instead of doing this two first, which takes a little bit longer for sure to do that, and then add 35, we get exact same result, only faster. That's why we want to understand this property. And our next topic is to estimate sums. Sometimes we want to have a quick estimate so that we have a quick idea how the answer is going to look like. So how do we do that then? You want to round the smallest number to the one non-zero digit. So in the first video, we learned how to round to have only one non-zero digit. Basically, we round the number to the very left digit. After you round all of this number to the same place, and you want to add this rounded numbers together. Now let's demonstrate that. Let's demonstrate this process. Example 6 says estimate each sum by rounding, then find the actual sum. So this is our first example. This is the second question. First, we identify which one is the smallest number, even though we only have two. So which one is smaller? Apparently, this one is smaller. The first step is we round the smallest number to the highest possible value so that it only has one non-zero digit. For us, this is the highest place value. Just remember we round it to the very first digit on the left side of the number. So this one going to be rounded to the thousands place. So that's 4,000, right? Can you imagine? And the rest of numbers, even though we only have one, also should be rounded to the same place. So this is a thousandth place. Now this digit to the right is smaller than 5. According to the rule we learned in the last video, we just we don't round this 8 up. We just replace all of these digits with zeros. So this is going to be 68,000. And the add together. Apparently, this is 4,000, this 8,000, add together is 12,000, right? If we do it this way, 4,000. This is 12 with carry, so that's 72,000. So this is estimate. The goal of estimation is that to get answer quickly, and the answer should be somewhat close to the actual answer. Otherwise, if you take a longer time to estimate, why not just do the actual calculation, right? If your answer is too far off from the actual answer, what's the point to even estimate that, right? So it's two general principle. One way to estimation is that it has to be faster, I like to say, and close enough to the actual answer. Okay, what is the actual sum? Let's add them together, right? 68,000 to 14 and 4,318. This is a 12 with carry. We get a 3 and 5. And this 12, another carry, 72,532. So that's very close to our estimation of 72,000. Now let's do another one. This time we have 3 numbers to add. We always look at the smallest number so that we round it to one non-zero digit. Apparently this is 70. It's going to be 70. So this equals, we run it to 10th place, in other words, for all of these numbers. So this one 10th place, we run it to 10th place. Since this digit after that to the right is 6, we run it up. But this digit happens to be 9 already. So run it up become 10. So we get a carry. So that this 8 become 9. So we get 5,900. Then next one, round it to 10th place. So this is 9, round this 3 up by 1 digit. So that's 540. And this one round to 70. Because 2 is smaller than 5, we just replace it with 0. Now we add this 3 together. So let's do it in here. 5,900, 540, 70. 0, 11 carry, 9 plus 1 is 10, 10 plus 5, 15 carry. So the answer is 6,510. What is the actual answer? So let's do actual one. 5,896 plus 539 plus 72. So let's add this 3 together. 6 plus 9, 15, this is 17. So we have 1 carry, 9 plus 1, this carry is 10. 3 plus 7, another 10, that's 20. We have another carry of 2. 8 plus 2 is 10. 10 plus 5 is 15. So another carry. 5 plus 1, 6. We get 6,507. The estimated 6,520 is very close, right? Very close. So you get an exercise problem. You do exactly the same thing. Estimate first, then find the actual sum. And the question itself is on the next page. Yeah, this is your exercise problem. Now, let's look at another topic. This time, we are going to solve some application problems involving addition. Now, let me say something in general, how to solve application problems. When you solve application problem, you want to focus on two things. First, you want to understand the information in the problem description so that you can determine whether you should do the addition. If you misunderstand the information, you choose wrong operations, no matter what numbers are in the problem, you're going to be wrong before you even start doing the calculation, right? So we want to understand the information first. Second one is that we need to understand clearly what is being asked. So we want to understand the question also. Okay, let's look at our first example here. Bob and Kim found out that the basic cost of building the house they have chosen is $212,500. They decide that they want to add some extra features. A wood burning fireplace costs additional $680. They also want to upgrade the fixtures and appliances at a cost of $3,158. What will be the total price of the house? Now, this is even though the description is kind of long, big paragraph, actually it's easy to understand. First, any upgrades will have extra cost in addition to the original price. We call it the base price, right? So in order to get the total cost, you have to add those upgrades cost to the original base price. So let's do the calculation after we understand it. The base cost is $212,500. And what are the additions? What are the additional costs? We have two numbers here. Fireplace is 680. And some other fixtures and appliances, 3,158. So now we need to add these three numbers together. So let's do the calculation. 212,500, 680, 3,158. See, I line up those digits according to their place values. 0 plus 8, still 8. And 8 plus 5 is 13, plus is a 1 carry. Oh, there's no carry, sorry about that. 8 plus 3, 8 plus 5 is a 13. So we have carry here. 5 plus 6, 11, 12, 13. And we have carry again, 2 plus 3, 5, plus 1 carry is 6, 1, 6. So the final cost is $216,338. So that's total cost after those two upgrades. Now you have a exercise problem, and it's very similar to the one we just finished. And this is the description and the information, those are numbers on the next page. So these are the numbers for your exercise problem. You have a base price, you have those additional costs, you need to find out the total. Now let's look at one more application problem. This is called example 8. The Jensens want to put a border on the walls of their son's room. The room is a 10-foot wide by 12-foot long rectangle. So the shape of the room is a rectangle. How much border material must they buy? So basically, this border material must surround the room, the rectangle, right? We all know rectangle has 4 sides. So the first question is, what information is given? We are given the length and the width of the rectangle. So as illustrated here, we all know a rectangle is a 4-sided figure where the opposite sides are parallel and equal in length. In this case, the information we need is that they are equal in length. Even though we only are given length and width, we know opposite sides are equal. Okay, so the total length, total material, amount of material needed, it has to be the amount that surrounds the 4 sides, right? So as a result, we add them together because our question is how much border material must they buy in terms of the length. So total length, the total length surrounding a shape is called a perimeter. So we are looking for the perimeter of the rectangle. So this is total length equals 12 plus 10 plus 12 plus 10. Basically, we just add these 4 numbers together. We learned commutative property of addition, right? Order doesn't matter in addition. So 12, that's 24, and 210 is 20. Now add them together, we get 44 feet. So in total, they need to buy 44 feet of the border material. So this is our second application example. And the answer is 44. Now let's look at subtraction. Let's look at the subtraction. When do we need subtraction? Whenever you take a number away from another number, you need to do subtraction. Also, whenever you need to find the difference between 2 numbers or how far away between 2 numbers, you need to do subtraction. So let's look at the first example. We call it example 9. Subtract 32 from 975. So we subtract this number from this number. And in subtraction, there's no commutative property. You cannot change the order of the 2 numbers. 5 minus 2 is not going to be equal to 2 minus 5. So that is why it is important to identify which number should be the first number, which number should be the second number in subtraction operation. So we subtract 32 from 975. So 975 has to be the first number because you do this is subtracted from this. So 975, 32. We also line them up according to their place values, right? 5 minus 2, that's 3. 7 minus 3, that's 4. There's nothing here. You can view this as an invisible 0. 9 minus 0 is 9. So our answer is 943. Once you take a number away from the original number will become smaller to make sense, right? To make sense. Now we have another example, example 10, 8,982 subtract 765. Why we do another example? Because in this one, we are going to do some borrowing. Let's look at this digit by digit. 2 minus 5, 2 is smaller than 5. You cannot take 5 away from 2. So you have to borrow. When you borrow from the digit to the left. One thing you need to understand is that we are using decimal system, which means every adjacent digit has a place value 10 times difference. That's why this 2 is in the 1st place and 8 is in the 10th place, 10th. So if you borrow 1 from 8, actually you borrow 10, not 1. Because for example, if we have digit 1 in here, this becomes 12. It's not 1, 2, or 3. This is 12. So whenever you borrow 1 from the previous digit, I mean from the digit to the left, you borrow 10 actually. So let's say we borrowed 1 from 8, it becomes 12. 12 minus 5, we get 7. Okay. After you borrowed 1 from 8, it becomes 7. 7 minus 6 is 1. Now 9 minus 7, that's 2. 8 minus 0, that's 8. So final answer is 8,217. But how do we know we did it correctly? If we did it correctly, when you add, this is how we check if the answer of a subtraction is correct or not. You add these two numbers together to see if you can get the original number. If you get the original number, your subtraction is correct. Apparently, this is true. 5 plus 7, that's 12. Carry of 1, 6 plus 1, that's 7. 7 plus carry, that's 8. Now 7 plus 2, that's 9. 8 plus 0, that's 8. So our answer is correct. Now we have another example about estimation. Estimate this subtraction by rounding, then find the actual difference. So whenever we estimate quickly, we want to round the smallest number so that it only has one non-zero digit. In this case, it's in the thousands place. So this becomes 8,000 because this 4 is smaller than 5. We just replace these 3 digits with zeros. And this one rounded to the same place, thousands place, that's going to be 45,000. So we do a quick subtraction. This is our estimation. If you can do it in your head, that's even better. So 8,000 subtraction, right? 15, we need to borrow. So this is 5 minus 8 borrow. 15 minus 8, this is 7. After this 4, then 1 to 5, it only has 3 left. So answer is 3. So estimation is 37,000. 37,000. Now let's look at actual subtraction result. 45,000 to subtract 8,473. We borrow 1. So what if it is 0? 0 goes this. If you borrow 1, 0 doesn't have 1 to lend to this 2. It will borrow from the 1 prior. So this one doesn't have any number in there. You borrow from here. So eventually, it borrowed 1 from 5. Since the 5 is in the thousands place, actually this is 1,000. Let's see if this makes sense or not. In terms of performing this operation, this is a quick way to do that. You borrow 1 from here, that is 12. 12 minus 3, that's 9. Then you treat all of the zeros as if they were 9. Because this one will borrow 1 from here, it becomes 10. But after it has 10, it lend 1 to 2, so it becomes 9. So treat all of 0 as if they were 9. So 9 minus 7, that's 2. 9 minus 4, that's 5. Since we borrow 1 from here, it's become 4. 4 is too small to subtract 8 when you borrow from the 1 to the left. So 14. 14 minus 8, that's 6. And this becomes 3. So our estimation is, our actual subtraction result is 36,529, which is reasonably close to our estimation, 37,000. So this is about estimation in subtraction, very similar to what we did for the addition estimation. Now you have an exercise problem here. You do exact same thing, just with different numbers, which are on the next page. So this is your exercise problem for estimation and subtraction. Now we have 2 more topics in this video. Let's look at how to solve whole number equations containing an unknown. This is our example. Suppose we want to buy an appliance that costs $350, but we only have 200. How much more do we need to have enough to make the purchase? First, this is very easy to understand information. We don't have enough money to buy the appliance. So in order to be able to buy it, we need to have more money in addition to the $200 we already have, right? So this translates into, we already have 200, we need some more in addition to 200, that means on the top of 200, we need some more. We don't know how much more because this is our question, right? How much more? But after we have this needed amount, actual amount, we will have this 350 to buy the appliance, right? So this is just a basic translation. We just try to represent this information correctly. But in algebra, usually, this is called pre-algebra, this course, right? In algebra, usually we want to use a letter called variable to represent the unknown. So we are going to replace this question mark with an x. 200 plus x equals 350. You don't have to use x. X is the popular one in textbooks. You don't have to use x. You can use any letter you want in theory. Now, how do we solve it? Whenever we solve equation, in the end, no matter how complex the equation is, in the end, we want to have this unknown x, in this case, on one side by itself, so that we have something looks like this, x equals a number. We call it the answer, right? So in solving any equation, the general approach is to get rid of anything that is on the same side as your unknown. You only want to have this unknown on one side by itself. So common sense says we want to move this 200 to the other side. We want to get rid of it. Now, whenever you move a number or even a variable to the other side of the equation, you want to change this to the opposite sign in front of it. So this one doesn't have anything, it's equivalent to positive. I know we have not learned positive, negative numbers. If there's nothing in the front, you can imagine there's positive sign. You can also call it a plus, at least for now. So we want to change it to the opposite, become a minus. So x equals 350 minus 200. So this plus become minus. Now, if you're not sure why we change the sign, I'm going to give you something really simple to see the truth, to see the fact. Say we have 8 minus 2 equal to 6. And you know that is correct, right? Suppose for some reason, I don't want this 2 on the left-hand side. So as a result, I move it to the right-hand side. Now, according to this rule, we want to change the sign in the front to the opposite. Change the minus to plus when we move it to the other side. Is it still true? After I change the minus to plus? Yeah, it is still true. What if I don't change it? If I don't change it, I still have minus. Is it true? No, it is not true. And that is why whenever we move a term, they call it a term or number, either a number or variable, doesn't matter, they are called terms. We change the sign to the opposite. So now let's do the calculation. 350 minus 200, 300 minus 200, that's 100. That's 150. So now we can answer the question. So we need $150 more in order to be able to purchase the appliance. By the way, how do you check the answer after you solve the equation? How do you know your answer to that equation is correct? Actually, all you need to do is put this number back into the equation to replace the variable. Or x equal to 150, replace this x with 150 to see if this makes the equation true. So right-hand side should be 350. Left-hand side, 200 plus 150, it is 350. They make equation, this answer make equation equal. So we get correct answer. That's our answer. Now let's do one more of this equation example. So this is pretty much like the previous one. We want to have x on one side by itself. So we simply move this 45 to the other side. We don't want it on the left-hand side. So x is plus. We don't need to write plus or positive. 73 minus 45. So 73 minus 45. We borrow 1 from 7. 13 minus 5 is 8. After we borrow 1 from 7, there's only 6 left here. 6 minus 4, that's 2. So answer is 28. So we solve it. Now let's look at what we have on the next page. Certainly you have another exercise problem solving this equation. Again, answer is in the comment area below the video. Now the last topic for today is that we are going to solve application problems involving subtraction. The last one was involving addition, right? Now we have, looks like we have 2 examples. Actually 3. I just have a pick and 3. A small computer business has $5,678 in their bank account. During 1 month, 2,985 is spent on parts for production. How much is left? So basically, spent means it's gone. It's not in the bank account anymore. So basically, we take 2,985 from 5,678 initial balance, right? This is a subtraction. You're going to have smaller amount after you spend some of your money. So basically 5,678 minus 2,985. So let's do the subtraction. 5, 6, 7, 8, 2,985. We do subtraction, right? 8 minus 5, that's a 3. 7 minus 8, we borrow. 17 minus 8, that's 9. After lending 1 to the digit to the right, we have 5 left. 5 is too small to subtract 9. We need to borrow again. So it becomes 15. 15 minus 9, that's 6. And this becomes 4. 4 minus 2, that's 2. So the answer is $2,693. So after they spend this amount on the parts, they have $2,693 in their bank account. The next example, again, whenever we have application problems, we want to focus on understanding information first, because that will determine what kind of operations we are going to do, even though this one is applications involving subtraction. So we already know we're going to do subtraction. But when you solve real life problems, nobody going to tell you this is from subtraction part of your textbook. You just have a problem to solve, right? That's why we need to focus on understanding information first. A room temperature 68 degrees Fahrenheit mixture. Oh, this is about a room temperature mixture of water and sugar is heated to boiling. That means the original temperature of the mixture is 68 degrees Fahrenheit. We want to heat it to 212 degrees Fahrenheit, which is the boiling point for water, so that more sugar may be added to supersaturate the mixture. So we don't need to worry about the purpose of heating the water to the boiling point. We just know that we are going to heat the water from 68 degrees to 212 degrees. The question is, how much did the temperature change? So basically, change can be found by doing subtraction. For example, what is change from 2 to 3? That's 1. How do you get 1? 3 minus 2. What is changed from 2 to 5? You say 3. How do you get 3? 5 minus 2. So change is a result of subtraction. So we are going to do subtraction. So the temperature change equals 212. Use a bigger number minus smaller number to get a positive number. Again, even though we have not learned positive negative numbers. So 212 minus 68, 12 minus 8, because we need to borrow, that's 4. After borrow, this 1 becomes 0. We borrow again, becomes 10. 10 minus 6, that's 4. 2 reduced to 1, 144 degrees Fahrenheit. So in order to heat the water to the boiling point, we need to increase the temperature by 144 degrees. And that's the temperature change. And here I list 2 different approaches. We already did approach number 1, which is the difference between 2 numbers. The change, the difference, you want to do subtraction. Okay, I'm going to write it down here again, 212 minus 68. That's the difference between 2 numbers. We call it change. The second approach is that you can write an equation, and then by solving equation, you also get the answer. So I'm going to get equation. We start with 68 degrees. We have to heat it to a higher temperature. That means this temperature, this number going to get increased. How do you increase the number? You add, right? So we don't know how many degrees are for now to add, to increase. We use X to represent that. And after we add this many degrees, we will reach boiling point. So now we solve this equation. So you already know by now, we move the 68 to the other side and change the sign to the opposite. When we see sign, always look at the front of the number. If there's nothing, it means positive. If it's negative, it's negative. So 212 minus 68, we know we are going to get 144 degrees. So we get exactly same answer. The last example for this video, another application problem. A charity organization has collected $43,587 through a fundraiser. The goal for the year is to raise $125,000. How much more is needed? So this is the current number they have, and they need more to reach a higher number goal, right? So let's solve this by using equations. Since in the real life, the vast majority of problems are solved by equations. So we start with 33,587. We need more in addition to this amount to reach a higher number. So that's why we add X to it. We're going to, after we adding X, we get 125,000. So now we just need to solve this equation. Move this number to the right side. X equals 125,000 minus 43,587. Now let's do the subtraction. We need to borrow again. 125. So 43,587. We need to borrow this. You cannot borrow from 0. So eventually we borrow from 5. So after borrow from here, this become 10. 10 minus 7 is 3. For the rest of zeros, I mentioned in the previous example on the previous slides, that you treat these additional zeros, except the first one, as if they were 9. So 9 minus 8 is 1. 9 minus 5, that's 4. This one borrowed one, lend one to the previous digits, it becomes 4. 4 minus 3 is 1. And 2 is too small, borrow again, it becomes 12. 12 minus 4, that's 8. And this is 0. So they need $81,413 more to reach their fundraising goal. How do we know this number is correct? Again, we add these two numbers together to see if we get back to 125. So our answer is 81,413. They need $81,413 more to reach their 125,000 fundraising goal. Now you got the last exercise problem. And this is the part of it. The other half, I guess, is on the next page. Okay. This is your exercise question. And that's all for today. And see you guys in the next video.